Hi students, this is lesson 6.3 and it is going to focus on sign analysis. So we're going to be given a real messy function and your job will be to determine which intervals will have positive outputs and which will have negative outputs. Okay, so into the pit we go, and here is our objective. I can determine intervals of positive values or negative values given a polynomial or rational equation using sign analysis. Okay, so the first thing we're going to do is on page 8 and 9 in your packet. What I'd like you to do is to determine what is happening in each step. Okay, so we're given, here's our original function here, this big messy thing. And if you're curious, you could also put this into Desmos just to get a visual of what's going to be happening. But we're going to try to find out what's going to happen using this sign analysis. So step 1, go ahead and write down on your paper what you think is happening. Please make sure you pause and take the time to really look at the work. Okay, so hopefully you're seeing that 0 was substituted for f of x. And what happened here is we use the zero product property. So this is using the zero product property. We substitute 0 for f of x, okay, which is our output. We use ZPP and we solved for the x-intercepts. Okay, so we have 1, 2, 3, 4 different x-intercepts that we have located. So that is step 1. Okay, step 2, see if you can figure out where these different values come from. So hopefully you determined on the top here, these were the x-intercepts. Okay, those were the 4 x-intercepts. And then on the side, these are the factors of the function. And the function's name, f of x. Factors of f of x. Those are all lined up right here on the left. Okay, so that's our step 2. Step 3, take a look at this and see if you can figure out what is going on here. Okay, so these are different regions. This is going from negative infinity up to negative 4. This is from negative 4 to negative 1, negative 1 to 3, 3 to 5, and the last region is 5 to infinity. Each region is broken by that x-intercept. So in each of these regions, we want to know, is this factor going to be positive or negative? Now, 0.00072 is positive no matter what region you're in, which is why these are all positive values. Here we're looking at an x plus 4. For example, you could say, from negative infinity to negative 4, let's put in negative 5. Plus 4 is going to give me negative 1. That's where the negative came from. You can plug in any value you'd like as long as it's in the region. Let's look at the next region from negative 4 to negative 1. Maybe I want to put in negative 3.99 plus 4. That will give me a positive value. We don't even care what the value is. We just want to know the sign, positive or negative. So looking through the rest of these, we're all positives. We do the same with x plus 1, where we get 2 negatives and 3 positives. And now look at this one. This is something, take away 3 squared. Remember, if you square something, you're always going to have a positive value. The only time you wouldn't is if you had 0 squared, which is just 0. But remember, 3 is one of the x-intercepts. So we're not going to ever plug 3 in. We already know that's an x-intercept. So that's kind of a gimme line, all positives. And then we'll do the same thing with x minus 5. So we are going to substitute a value into each factor to determine a positive or negative output. Okay, that is our step number 3. Step 4, go ahead and pause and let's see if you can figure out what happened. This is the new part down here. Okay, now remember, f of x is a product. This times this times this times this times this. All those multiplied together equal f of x. So again, f of x was 0.00072 times x plus 4 times x plus 1 times x minus 3 squared times x minus 5. So, looking at this first column, if we multiply a positive, a negative, a positive, and a negative, we end up with a negative. We don't even care what the number is. We just want to know the sign. Is it positive or negative? This will tell us if the graph is above or below the x-axis. And it's going to ultimately help us sketch this polynomial. The next one we have positive, positive, negative, positive, negative. Remember, the two negatives are going to kill each other off. We get a positive outcome. Positive, 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 positive. Oh, just one negative. We have a negative product. 1, 2, 3. But these are all positive. Same thing here, one negative. And these are all positive, which of course is going to give me a positive product. Okay, so this is overall f of x. If we plug a number in from negative infinity up to negative 4, will the result be positive or negative? That's what the line down here is telling us. Okay, so for this next step, it says f of x is greater than 0, positive, for these regions. And it's negative for these regions. So we are going to name regions of positive or negative values. And this is called sign analysis. Sign analysis. Okay, now the last part of this would be to try to graph something. So that region initially is negative. Then we have something positive. Then negative, and then negative again. Well, look, it's got to hit the x-axis. 0 is neither positive nor negative. And then it bounces off. And then it goes up like this. So what you could absolutely do is type in that original function. Look on Desmos. It is not going to match mine. But what should match at this point are the x-intercepts and the regions of positive and negative values. So in this case, we can sketch. We're not actually doing a graph. A graph would be more zoned in on accurate points. This is just a general sketch. So sketch using the x-intercepts. Those are valid points on here, and positive, negative regions. Okay, let's give one of these a try. If you feel good right now, you could certainly pause this and try this. If you want to still work with me or do a little and pause and unpause, that's fine too. So step 1 is to find those x-intercepts. Okay, so I put a 0 in for g of x, and now I'm going to use ZPP, zero product property. That means if all of these things multiplied together equal 0, no matter what, one of those factors must be 0. There's no other way to have this be true. So negative 4 equals 0, well, of course it doesn't. So that factor we know is not 0. We can put x equal to 0, x plus 3 squared equals 0, and x minus 1 equals 0. Now we need to find all the x-intercepts. Well, that one's already found for us. We could take the square root of both sides, and then x equals negative 3. There's another x-intercept. And the last one is just x equals 1. 3 x-intercepts. Now is when we make our table for sign analysis. Now remember, those x-intercepts, those are going to go above, and we want them to go in the order that they appear on the number line. So we need -3 first, then 0, then 1. Notice I really don't care that they're evenly spaced or not. We're just looking at these regions. We want the x-intercepts, though, to go in the order they appear from left to right. So this is from -3 to 0. I like to write my regions up here so that when I'm done, I just go ahead and collect which ones are positive, which ones are negative. Now we're going to write every factor on the left side. So -4 is the first factor, x plus 3 squared, we can keep that together, that's fine, and then x minus 1. So the gimme right away is at -4. No matter where I'm at, what region, it's always negative. So that's nice. I also see another gimme. It's this x plus 3 quantity squared. Anything I plug in, positive or negative, and square it, I'm getting a positive value. Okay, so let's look at this one with x. We're going to plug in a value. So let's plug in -4. Well, -4 is obviously just going to be negative. From -3 to 0, I could plug in, let's say, -2. Still negative. From 0 to 1, I could plug in a half. That's positive. And from 1 to infinity, I could plug in 10,000. That's positive. Any number within the region is good to test. Now we have the input take away 1. So let's say I use -4 again. So that's -4 take away 1. That's going to be a negative. Again, I don't care what the value even is. We just want to know at the end, is it positive or negative? Let's say I plug in -2. -2 take away 1 is negative. If I put in 1/2, 1/2 take away 1 is negative. And let's say I plug in 2. 2 take away 1 is positive. Okay. So once that's done, now we want to find out, okay, for the whole function g of x, from the region -infinity to -3, will I be above or below the x-axis? Well, if I have two negatives times each other, that's a positive. Times positive is still positive. Oh, we got a negative here. That will be below the x-axis. Same thing here with the second region. That becomes positive. Times positive is positive. Oh, negative, negative. Now this third one, the negatives, the two negatives times each other are positive, and then we just have positive remaining, so that's positive. And the last one will be a negative. So from here we can say intervals of positive are, let's see, the intervals are only the 0 to 1. That's it. That's the only interval that's positive. And intervals of negative are from -infinity to -3, union -3 to 0, union 1 to infinity. So we have three regions that are negative. If you were to try to sketch this, and it didn't ask us to, let's see, we're at -3, so we want the x-intercept here at -3, at 0, and at 1. The region to the left of -3 is negative. So I'm just going to do something like this. And then, then it's negative again. So I'm going to do this. Then it's positive, and then it's negative. Now again, if you were to go ahead and graph this for real, you would get some more points. You'd get probably some points really in all the regions to solidify this a little bit better. But this gives us a general sketch, a general idea of what's going on. A real important observation is the end behaviors. So that's something that you can definitely tell using this sign analysis. Okay, we'll do some more practice in class. Thanks for watching the video and taking notes. Don't forget to upload them, and I will